Good morning, dear friends. Welcome to Physics Hub. Today, let's discuss about a very interesting device, AC generator. You know that AC generator is a device which converts mechanical energy into electrical energy. You might have seen this AC generator or AC motors in the small toy cars and especially in the cycle dynamos. You can see that. So, in this session, let's study the theory and working principle and the description diagram of this AC generator. So, basically, you can see this AC generator consists of a rotating shaft which is connected to a rectangular armature coil. The armature coil, by this armature coil, we mean that a coil which is a rectangular in shape wound to a rectangular frame, hollow rectangular frame. Okay, this armature coil is actually placed in between two strong field magnets marked as north and south. We are placing the strong field magnets on either side in order to produce a uniform magnetic field. And also this uniform magnetic field is strong. So what happens now? When we rotate the shaft from outside, the armature coil connected with the shaft also will rotate. This rotation is actually happening in between the strong uniform magnetic field. So we more clearly we can say the rotation is happening by cutting the magnetic flux flowing in between two field magnets. So at this time what happens now? According to Faraday's law of electromagnetic induction, Faraday's law of EMI, we know that whenever there is a change in magnetic flux associated with a conductor, an EMF is induced in a conductor. So, also it states that the EMF induced will last as long as the change in magnetic flux persists. Here, there is a change in magnetic flux due to the rotation of this coil, rectangular coil. So that an EMF will induce or an EMF is generated in this rectangular coil. This EMF is known as AC EMF. By using this induced EMF, that the bulb or any other device connected at the output will operates. Just like in cycle dynamos, when we ride the cycle too fast by connecting the dynamo to the back wheel, we can see that the bulb uh, in front of the cycle dynamo will glows. Whenever we stops the cycle, it will diminish. Okay, then we want to take this induced EMF to outside, then only we can use it, is it? So to take this induced EMF to outside, to bring this induced EMF outside, what we do, we connect two rings, metallic rings, small metallic rings known as slip rings. In the figure it is marked as S1 and S2. This S1 and S2 can also rotate along with the rotation of the armature coil. One more thing I forgot to say, the field magnets are actually stators, are called stators because these are the stationary part inside a AC generator. And the armature coil, the shaft and the slip rings are known as rotors because it can rotate or move. These are the rotating parts inside an AC generator. More clearly in this manner we can see. So here the current or the EMF generated, as I said, is actually an alternating current. So the current will pass through these slip rings. So the current which is or EMF which is induced in these slip rings is to be taken outside by means of two brushes made up of carbon. So we can say B1 and B2 are brushes made up of carbon which just touches the slip rings S1 and S2. When the EMF is passed through the slip rings S1 and S2, the carbon brushes which touches this rings S1 and S2 will bring out the EMF when the more clearly we can say when the slip rings rubs the carbon brushes, this induced EMF is taken outside. So once the EMF will be in this direction, At the next moment, the EMF will be in the opposite direction. So this will continues to form an alternating current, and if we draw the graph of output in which the angle of rotation is taken as x-axis and the induced EMF is taken as y-axis, this will be our result. Here the peak is marked as E0. In the negative y-axis, this is marked as minus E0. So let's explain the graph in a brief. By the laws of electromagnetic induction, we know that E is equal to minus d phi by dt, where phi is the magnetic flux associated with the conductor. Also we know that phi is equal to Ba cos theta. So I am writing Ba cos omega t as theta is equal to omega t by using the rotational analog. So what will be d phi by dt? D phi by dt will be minus Ba omega sine omega t. As I have said, the armature coil has not only one number of turns, but it have capital N number of turns. That is, so many number of turns, let's call it as capital N. So for n number of turns, we can write d phi by dt is equal to d phi by dt is equal to minus nba omega sine omega t, where capital N is the total number of turns. So E is equal to minus d phi by dt. So substituting this, we get nba omega sine omega t. So the EMF generated will be maximum if and only if the value of sine omega t is equal to 1 or omega t is equal to pi by 2. So that EMF will be equal to nba omega. That's it. So this nba omega is called as E0, which is the maximum EMF. In the graph, E0 is marked as here, the peak. So this equation just resembles the wave equation, sinusoidal wave equation, that is equal to y is equal to y0 sine omega t. Same like this, is it? So like that we get a sinusoidal graph. So by plotting the graph, plotting the variation of EMF with respect to time at pi by 2, pi, 3 pi by 2 and 2 pi, we clearly get a sinusoidal wave, which represents that the output current formed is an alternating current, not a steady current, just like the current from a battery or cell, like that. So this is all about the explanation of AC generator. Hope you like this video. If you like this video, like, please give a thumbs up, share this to your friends and subscribe our channel. Thank you. Have a nice day.